Hi everyone, my name is Jamie Gorson. I'm a PhD student at Northwestern University in the Delta Lab, and I'm very excited to share with you the work that my advisor Eleanor and I have been doing. Today, I'm going to talk about our research on how students assess their programming ability and how these assessments might impact their self-efficacy. Self-efficacy is important for us to consider because it can influence students' persistence through their academic major. We know from work done by Lewis et al. That a student's perception of their programming ability contributes to whether they decide to major in CS. Many CS programs still struggle with high dropout rates, even though CS1 failure rates have improved. We're trying to improve retention in CS programs by understanding how students evaluate their programming ability and how this impacts their self-efficacy. As you may remember from the previous presentation, self-efficacy is an individual's belief in their ability to complete a task. Self-efficacy is influenced by many sources of information, one of which is how students evaluate their performance on tasks related to subject mastery. Going forward, I will call these self-assessments. So if students' self-assessments are often negative, then they will have lower self-efficacy. In this talk, I will explore the moments in the programming process that cause students to make negative self-assessments. So how do CS1 students assess their programming ability? A few studies have explored this question, and they found that CS1 students make frequent self-assessments that can often be negative, even after positive programming episodes, when students' programming process does not meet their expectations. The study suggests a number of criteria that students use to make self-assessments. In our previous work, we also found that CS1 students assess programming ability often. We identified 14 criteria that students use when making these evaluations, which you can see here. Many of the criteria that we identified were surprising because they are natural and expected parts of expert practice. For example, we found that students consider that getting errors or asking for help is a sign of low programming ability. I want to clarify that self-assessments are not inherently bad. In fact, self-assessments are critical for directing an independent learning process. But if students are negatively evaluating themselves often for reasons unrelated to CS proficiency, then they may be having a more negative experience and lower self-efficacy than we would expect. While many of the criteria from the previous study relate to moments in the programming process, we only asked about the criteria broadly instead of in relation to specific moments. So in this study, we asked, when presented with scenarios of programming moments, which do students say cause them to negatively self-assess? We were also interested in learning if these moments are different across university populations. So we asked, are there any differences in the moments that cause students to negatively self-assess across university contexts? Next, we wondered if these self-assessment moments impact students' self-efficacy, so we asked, do students who report negatively self-assessing in response to more moments have a lower self-efficacy in their CS course? Finally, we want to learn more about why students use these criteria even though they are part of expert programming practice. So we asked, do students' perceptions of professional programming practices correlate with the moments that cause them to negatively self-assess? To address these research questions, we ran a survey study with 214 introductory CS students from 3 different universities. These universities are all in the same metropolitan area, but serve different populations of students. All of our participants were enrolled in a CS1 course at their university. We decided to use a survey because it allows us to measure each student's reaction to the same set of programming moments. This would not be possible in an observational approach because the same events will not naturally occur for each student. Our survey has 3 sections. The first section of our survey is a 5-question academic self-efficacy survey, which we modified to ask about a CS1 course instead of coursework generally. For example, one of the questions is, I'm certain I can master the skills taught in my CS1 class this term. The second part of our survey measures the moments in the programming process that elicit negative self-assessments. To do this, we developed vignette-style survey questions that ask students read a short story about a character during a particular programming moment. For example, to measure if students negatively self-assess when they use resources to look up syntax, participants read this vignette. Arjun is working on a programming problem. He can't remember the syntax. He uses Google to look up the syntax. He is disappointed that he cannot remember the syntax on his own. Following the vignette, we asked students to answer a Likert scale question about how they would react in a similar situation. So after this vignette, we asked, how much do you agree with the following statement? I feel like I'm not doing well on a problem when I can't remember the syntax and have to look it up. We designed 13 vignettes in total, which each ask about one of the self-assessment moments listed here. We chose to use vignette-style survey questions because they encourage participants to recall similar programming experiences. Studies show that participants often provide more reliable responses to survey questions that reference specific past experiences, in contrast to a direct question. In the final part of this survey, we explored students' perceptions of professional programmers with the goal of learning about students' expectations about the professional programming process. We measured this through survey questions that asked students to finish a sentence starting with professional programmers with one of two options. For the self-assessment moment, using resources to look up syntax, students picked either 1. Remember the syntax they need and rarely have to look it up, or 2. Often forget the exact syntax and use Google and other resources to help them remember. We wrote a question about professional programmers that aligned with each of the self-assessment moments so that we could evaluate if there was a correlation between students' perceptions of professionals and their self-assessments. Following the surveys, we conducted 13 follow-up interviews with students from across the 3 universities. The goal of the interviews was to confirm that students interpreted the vignette questions in the way we intended and recalled moments from their own programming experiences. We asked participants to read through each of the vignettes and explain their rationale for their responses. All right, we are now ready to discuss what we found. In research question 1, we wanted to identify programming moments that cause students to negatively self-assess. First, we looked at histograms of the self-assessment vignette questions. In the histograms, we saw a couple of different patterns in students' responses. For example, we noticed that most students agreed with some questions, like not knowing how to start. And then for others, most students disagreed, like forgetting a simple error. Other questions were more evenly spread or had bimodal distributions like those here. For both the starting over and spending a long time on a problem moment, we can see 2 distinct peaks, one on disagree and one on slightly agree, showing variance in students' responses. Overall, we found that some students reported to negatively self-assess at each of the moments. However, there was a wide range of agreement. Importantly, we found that some students self-assessed during all of the moments. We found these results very exciting because they provide us with new insights into the moments that prompt most students to think they are doing badly while programming. But before drawing too many conclusions, we wanted to make sure that students understood the vignettes and responded based on recollections of their own programming experiences. In the interviews, we found that participants often mentioned their own experiences. For example, one participant said, "The question was kinda cool for me because Diego had to get help from the instructor and I often have to get help from the TAs a lot, and I don't feel like I'm doing bad. Like, I feel like I'm just improving myself." We also found that students generally were confident in their responses and could explain their reasoning. For example, another participant told us, "Yeah, I definitely feel bad when I have to spend time planning and can't start programming right away. As a computer science student, we don't have to think after reading the question that, okay, this is the plan going on in my mind. Rather, we should implement it and we should write it whatever way we feel, and by running the program, we can get to know the error instead of wasting time in the beginning." In research question 2, we wanted to know if there are any differences in when students self-assess based on their university. We used a Kruskal-Wallis test, which is a non-parametric ANCOVA, to compare students' responses to the self-assessment vignette questions across the 3 universities. We found that there was a significant difference for only one of the self-assessment moments, which was for the moment not able to finish in the time expected. This is surprising because the population of students at each university was very different. This suggests that most of these moments are generalizable across different university contexts. We wanted to determine if there is a correlation between using these self-assessment moments and student self-efficacy in their CS1 course. To answer research question 3, we calculated 2 compound measures. First, we averaged each student's responses to all 13 vignette questions to determine the frequency and strength of their overall self-assessments. Next, we calculated a compound self-efficacy score by averaging the 5 self-efficacy survey questions. Then we evaluated if there was a correlation between the compound self-assessment score and the compound self-efficacy score using a Spearman rank correlation coefficient. We got a p-value of less than 0.001, showing a significant relationship. This shows that students who negatively self-assess more frequently or strongly tend to have a lower self-efficacy in their CS1 course. While we cannot determine from this data if this is a causal relationship, self-efficacy theory states that if students repeatedly make negative self-assessments, they will have lower self-efficacy. So this suggests the possibility that there is a causal relationship between negative self-assessments while programming and self-efficacy. Finally, for the 4th research question, we explored the relationship between the moments that students negatively self-assess and their perceptions of professional programmers. First, We found that students often believe that professionals do not encounter these moments, which does not align with research on professional programmers. Based on those results, we hypothesized that students who think that professional programmers do not encounter the self-assessment moments might be more likely to negatively self-assess when they experience those moments. So, we ran a Man-Whitney U-test for each moment to evaluate if this correlation exists. Here are the results. You can see that we found a significant relationship for 6 of the moments. This suggests that students' perceptions of professional programmers may be one factor influencing why students make negative self-assessments. It is not surprising that there was not a correlation for all of the moments, as there are likely many reasons that cause a student to negatively self-assess. To review, we conducted a survey study with CS1 students from 3 universities. We identified moments that prompt students to negatively self-assess, even though they occur in professional practice. There was no significant difference in response across the 3 universities to 12 of the 13 moments, and the frequency with which students negatively self-assess correlated with their programming self-efficacy. And finally, students' perceptions of professionals correlated with some of the self-assessment vignette questions. Overall, students negatively self-assess in response to moments that occur in professional practice, which can negatively impact their self-efficacy. There are some limitations to this work. First, while the interviews increase our confidence in the survey, they could use further validation. Secondly, cultural differences, especially in different countries, may impact the moments that cause negative self-assessment. In the future, we are interested in exploring whether we can design interventions to reduce negative self-assessments. We hope to increase self-efficacy by helping students build accurate expectations of the programming process through teaching professional programming practices in CS1. I want to thank the Delta Lab for their support and our research partners for allowing us to survey and interview their students. On this slide is a link to our full survey. I look forward to your questions.